Hello Math20-2 and welcome to your first lesson of your new unit trigonometry. This first lesson here is just going to be a review, so we're going to just go over some things that you learned before on trigonometry and SOHCAHTOA, sine, cosine, and tangent. So, for this lesson you will need your calculator and just your book. So, here we go. First of all, we're going to look at example 1. Okay? And we're looking in example 1, we have to know our relation. So our relation is sine is always equal to opposite over the hypotenuse. Cosine is always equal to adjacent over the hypotenuse. And tan is always equal to opposite over adjacent. A little abbreviation for that is SOHCAHTOA. Sine, or written like this, SOHCAHTOA. Okay? Now, the hypotenuse is always your angle that is or your side that is opposite of the right angle. So it's only the line that does not touch the right angle. It is opposite of the right angle. The opposite side changes depending which angle we look at. So right here, if we're looking at this angle, the opposite is this side here. If we're looking at this angle, the opposite is this side here. Okay? And the adjacent for x is this here. Also, the hypotenuse is adjacent, but we're not going to say that because the hypotenuse is a specific thing. We're only looking at right angle triangles. Here we go. Question number 1. We want sine x. So we take a look at that. It's this angle here. Where is sine x? Sine is opposite over hypotenuse. Well, my hypotenuse is right here. The opposite is going to be dE. So we have dE all over FE. Now we're going to look at cosecants. Cosine is always adjacent over hypotenuse. So my adjacent to angle x is the one touching it, which is this dF. Now the hypotenuse is once again, never changes, is EF. Now we're going to look at tan x. So tan x is going to be my opposite dE over adjacent. Okay, there we go. Now let's take a look at sine y. Sine y, here's my angle y, and we want, once again, opposite over hypotenuse. So my opposite in this case is Vs, because Vs is opposite of y. Okay? It's the side farthest from y. Now my adjacent, well, my adjacent is here, my hypotenuse is here, and we want the hypotenuse. Okay, which is actually adjacent to an angle. That's the hypotenuse because it's opposite of 90 degrees. So that is VT. Now we're going to look at cos y. Cos y, first of all, cos is cos, which is adjacent over hypotenuse. So my adjacent of y is going to be right here. It's the one touching. Actually, my hypotenuse is also adjacent to y, but that's the hypotenuse, it's more specific. So we just want this adjacent here, which is TS. And TV is my hypotenuse. Okay? And tan, opposite over adjacent, so we're going to go VS all over ST, sorry. Okay? So there we go. Next question. So right now, this was just find the relations. It says, what is sine x? As soon as we talk about sine x, it's talking about the relationship. So sine is always talking about the relationship of your opposite over hypotenuse. That's what this means. It's just your relationship. Okay? Find your angle. Now, I'm going to take a look at the next one. And we did the relationships in the one before. So now we're just going to go with the relationships a bit more, and we're looking at them with numbers. So here we go. We're going to use the Pythagorean theorem to calculate the length of ST. So we're giving our triangle right here. The problem is we do not know ST. Well, where is my hypotenuse? 25 is my hypotenuse because it's opposite. The Pythagorean theorem is c squared is equal to a squared plus b squared. But here, what is known? We're trying to find, we'll call this a, side a, because we don't know this side. It's one of the legs. So then a squared is equal to c squared minus b squared. All we have to do is we subtract b squared from both sides. And that's how we get that. Okay? Now we continue to put in what we know. 25 is the hypotenuse. So we're trying to find a squared, right? Is equal to 25 squared minus, and we know 7. 7 squared. So that's equal to 625 minus 49. Okay? We continue this, I'm going to get 576. I want the square root of 576. So I'm going to use a calculator to figure that out. That gives me 24. Okay? So 24 is our answer for this one. So we know this length here is equal to 24. Now, state as a rational number the values of the following trigonometric ratios. So sine r. So we want sine r. So here's angle r, and sine is opposite over hypotenuse. So the ratio is 24 all over 25. Okay? Now we want cosine. Cosine is the ratio for cosine is always going to be adjacent. So the adjacent is 7 over 25. So it's 7 over 25. And then we want tan. Well, take a look at tangent. That is 7 over, or sorry, it's opposite over adjacent. So it's 24 over 7. So always remember SOHCAHTOA. Just write it down. Okay, SOHCAHTOA. All right, now sinus. Let's take a look at sinus. I have an angle there. And so there's my angle. Opposite. The opposite of sine is 7. And my hypotenuse, for the triangle, hypotenuse is the one that never changes. Okay? And we look at cosec, so adjacent is 24 cosine, so 24 all over, and the hypotenuse is 25. And tangent, so opposite of the tangent is right there, 7, adjacent is 24. Okay? There we go. So, comment on any relationships that we see between these. Well, if I look at this, these two are very similar. They are reciprocals of each other. Also, this cos is the same as this sine. And sine r is the same as cosine s. So basically what's happening here is, if we're looking at this angle, my adjacent and opposite switch compared to r. So they're interchangeable depending which angle we're looking at and which relationship you're going to be looking at. Okay? Alright. Example number 3. So example number 3 is a word problem. So we're going to take a look at this here. It says the telephone pole is, I'm just going to turn it away. The telephone pole is 12 meters high and supported by a wire 14 meters long. So we have 12 meters high, supported by a wire 14 meters long. That is going to the ground. Okay? So this is 12, this is 14. And then it says, first at the top, draw a sketch, the diagram, so we sketched it. Now, every time I've known poles, most of the time they're done, right? They should be 90 degrees to the ground. They should be pretty good. Okay, draw a sketch to illustrate the information to the nearest degree. So we want to find the angle between the wire and the ground. So this angle here. Now, looking at that angle there, what is my opposite and adjacent? So this is my x. I could do this in two ways. I could go either sine x is equal to, well, opposite over hypotenuse. So that's going to be 12 over 14. Now, why did I use sine x? Well, because this is my opposite and this is my hypotenuse. So I only know the hypotenuse and opposite. Those are the two known. So I'm going to choose sine x. I go back up here to SOHCAHTOA. I know opposite and hypotenuse. The only one is SO. I can't use cosine because I need to know the adjacent, which I do not know. Okay? I can't use tangent because I need to know the adjacent and the opposite. So I have to use sine. Now, take a look at this. This is just to find my ratio, but I want to find the angle. So then x is equal to okay? So we have this here. Now, key thing is we're going to now calculate this in our calculator, all right? Because we have to get the angle by itself. If we're doing that, it's just going to do that. So in our calculator, we have to push certain buttons here. So first of all, make sure your mode is on degrees and not on radians, okay? There we go, done. Now, next thing is we're going to put in, because if we look at this, it is sine to the -1. It's not sine. We're never trying to figure out the angle of sine to the -1. So I'm going to go second sine. Okay, so I push the second button, and then I push the sine button, and then I'm just putting in my ratio. Oops. 12 divided by 14. And enter. So I get my ratio to be 59 degrees. And that is it. Okay. Here's our next part here. So this is just continuing explaining how to find the ratio. Now there's different steps here. It depends on if we don't know a side and we know an angle, we can also determine the other side, okay? If we know an angle side, we can determine the other side with the ratio. Because there's really three, if you look at this, there are three variables in sine, cosine, and tangent. So if we know two of those, we can always find a third one. So I'll let you guys do these first ones by yourself, and we're going to continue on to example number 4. So example number 4 says, use a trigonometry ratio to determine the lengths AB and AC of the given triangle. So we know 74, and we know this angle here. This angle is what of 74? That is the adjacent. So this is adjacent. Okay? We don't know the opposite, and we don't know the hypotenuse of 74. If I wanted, I could use this angle here, because from the unit before, all triangles add up to 180. So this here would have to be a total of 26 degrees. Okay? Or sorry, 16 degrees. So now, we're going to look at this here. So this could be 16, but we're going to look from the angle 74, which is given to us. So, what do we know? We know adjacent. So if I'm trying to first find the opposite, let's try and first find AB. That is the opposite. AB is equal to the opposite. So we have to use, we look at SOHCAHTOA. We are going to have to use tan, because we know the adjacent and we want to find the opposite. So let's take a look at this. So we're going to go tan 74, tangent 74 is equal to opposite over adjacent. So opposite over my adjacent, which is 109. Okay? So we're going to rearrange this equation, so the opposite's by itself. So I multiplied both sides by 109. I end up getting 109 multiplied by tan 74 will give me my opposite. So I'll put that in my calculator. So I'll show you 109 multiplied by, we put in tan 74, bracket, gives me a total of 380. Okay, so that gives me 380 feet. My measurements, so this is. Now, next one is we're going to look at h. Okay, so now adjacent and hypotenuse, we're going to use cosine. So that is cos 74 is equal to, we know the adjacent, ka, which is 109 divided by h, the hypotenuse. So we take a look at this now, there's a problem. The hypotenuse is on the bottom. Do we ever like numbers on the bottom? No, we normally want to find one on top. So if there's a variable on the bottom, we have to put on top, so we're going to multiply both sides by h. So I'll multiply this side here by h. So now I'm going to get h. Hypotenuse multiplied by cosine of 74 is equal to 109. So now we're going to isolate h. So I divide by cos 74, cosine of 74, both sides. Okay? Now, we end up getting, right here, divide both sides by cosine 74. So we end up getting the hypotenuse is equal to 109 divided by, so let's try that in my calculator. So I'm going to go first here and push cosine 74. So I'm going to go cos 74, enter. It gives me that. Now I'm going to store this as something, so I'm going to go store this alpha x. So that's my x value. So now I'm going to go 109 divided by x, because that was that value, which gives me 395. My hypotenuse is equal to 395 feet. Okay? And that's what we want. Last question. Okay, so we take a look at the last question here. It says, a large tree is transported to a new location. The tree is held vertically by means of two guy wires of equal length on the opposite side of the tree. So one of the wires makes an angle of 48 degrees to the ground. Okay. The other wire is 12 meters long and makes an angle of 56 degrees with the ground. Okay. So both are attached from 3 meters down from the top of the tree. So illustrate this scenario below. So if we take a look at this here, we have the tree is held vertically by means of two guy wires. So we will have one up here. So they're of equal length, opposite sides of the tree. One wire makes an angle of 48 to the ground. The other wire is 12 meters long and makes an angle of 56 to the ground. Okay? Both wires are 3 meters down from the top of the tree. So they're like this. Both wires are like this. And it's 48 degrees with the ground, so this one's 48. And this one here is 56 degrees. Okay? So we illustrated our scenario and we have a triangle like that. Now, I'm going to assume right angle, right angle. Now, determine the height of the tree to 1 decimal place. Okay, so one wire. So this wire here, the other wire, this is 12 meters long, right? So if we have that wire there, we want to figure out this height here, and then we add another 3 meters, and that gives us to the top of the tree. So we have to figure out the height that goes up. So we know the hypotenuse, and we're trying to find the opposite. So we're going to go sine. Sine 56, and we're going to look at angle 56, is equal to, we know the hypotenuse, and we want to find the opposite. So it's 12, and we're trying to find the opposite because of SOHCAHTOA. I'll write down SOHCAHTOA again, just so you can see. Okay? So we continue this. That's an O, not a 0. Okay? So we're going to continue this. We have to get the O by itself. Okay, so we multiply both sides by 12. Multiply by 12. So I'm going to get 12 sine 56 is equal to my opposite. So let's plug that into our calculator. We're going to go 12. And then we go sine. And what was it again? 56 degrees. Enter. That gives me 9.94. So I'll say, what is it? To the nearest 1 decimal, so 9.9. So my opposite is equal to 9.9 meters. Or is it, yep, meters. But we know it's 3 meters taller, so I have to add 3, which gives me 12.9 meters tall. So the next one says, determine the length of the other wire to 1 to the nearest tenth of a meter. So now we have to determine the length of the other wire, which is this. So this is my x. We know this height is 9.9. Okay? So let's try this out. Or I'm just going to store this now. So I'm going to go store this answer as x. Enter. So then it's never rounded. I just stored it as x. So anytime I push x in my calculator, that number pops up. So let's take a look at this. So we know, once again, from this angle, we know the opposite, and we know the hypotenuse. Except this time we don't know the hypotenuse. So we know the opposite, and we want to find hypotenuse. So we're going to use sine again. So we're going to say sine 48 is equal to my opposite, which is 9.9, all over my hypotenuse, which is my x value. So now we want to solve for x. First of all, x is on the bottom. That never looks good. We don't like our variables on the bottom. We want them on top. It just makes more sense to have them on top and not on the denominator, not on the numerator. So we get x sine 48 is equal to 9.9. Well, now we can get x by itself. We just divide both sides by sine 48. So then we end up getting x is equal to 9.9 divided by sine 48. So if we use our calculator here, for x divided by bracket, and I'm going to go sine 48 bracket. Okay? Because x is that value there. And I'm going to end up getting 13.3 meters. Okay? So we get 13.4 meters because we have to round up. So I get 13.3, so it's 13.4 meters long. So now we know both wires. Next is determine to the nearest tenth of a meter the horizontal distance of the ground between the two guide wires. So now it wants us to find this distance here. I'm going to do them in two completely different ways. One, I'm going to use the Pythagorean theorem. That's this one here. And the other one, or sorry, this one here, I'm going to use Pythagorean theorem. And the other one, I'm going to use the trig ratio. So I'm going to go c squared is equal to a squared plus b squared. So we have two triangles with the distance we have to get. So a squared, we know the hypotenuse is 12, is equal to c squared minus b squared. So I'm going to get 12 squared minus 9.9 squared. Okay? So I'm going to try that out. We are going to get 12, put that in my calculator, 12 squared, enter. We're going to subtract, bracket, and my x is still that 9.9 if I remember right. 9.9 squared, put in brackets, enter. So I'm going to end up getting 45. Now, that is a squared is equal to 45. Well, what is a equal to? We have to square root this. Okay, so I square root it, and I get 6.7. So we get 6.7 meters. Now, let's find the other one. So my other one is we have, I'm going to use, for this triangle here, for this triangle, I'm going to use the trig ratios. So we know the hypotenuse, and I know this one here, this one I know best. So I'm going to use tan. I could use cosine, I could use sine, because we know, but I'm going to use tan. Or we could use, so tan 48 is equal to opposite, which is 9.9, over my adjacent. Okay? So we take a look at this again. We want the adjacent by itself, so I'm going to get a. So okay. Somehow we're just going to put that there, turn off the knob, make it better. So let's take a look at this. We want 9.9, which was my x, and we're going to divide that by bracket, and I'm going to say tan 48. Tan 48. Back. So I'm going to get 9. 8.95, so that's 9. So that is 9 meters long. Okay, now we have to add these two together. So I go 6.7, so I go plus 6.7 is equal to 15.6 meters. Right? Because this is 9, this is 6.7, and I'm going to end up getting 15.6 meters. So we have to add those two together. Okay? So that's my answer. Next one is E. Okay, it says, the guy wire in C breaks. A new wire the same length is attached 2 meters down from the top of the tree. Calculate to the nearest degree the angle which this wire makes. Okay, so it's 2 meters down from the top of the tree. So this one here is now 2 meters down. So we take a look at this. This wire breaks, so now it's 2 meters down from the top of the tree. It's still the same length of the guide wire in C. It's still the same length, so it's still 13.4 meters. Okay, but now it is only 2 meters, so it's way up here. All right, so this distance is 10.9. So my distance here is 10.9. So that's my opposite. And we want to find out this angle here. So we know my opposite is 10.9, and we know my hypotenuse is 13.4. So once again, we're going to have to use sine. So we know sine x is equal to 10 opposite over hypotenuse, because it's sine. So we go sine x is equal to 10.9 divided by 13.4. Okay? But we don't know this, so then we have to go x is equal to, because we're trying to find the angle, so we have to second sine. We have to go with the inverse of sine. So let's put that in the calculator. I'm going to put that in my calculator here. So we have this right here, which we're going to put to my calculator. So let's try. So that's second sine. Now we're going to end up going 10.9 divided by, and we have 13.4. And I end up getting an angle of 54 degrees. Okay, and that's everything. That's how we solve that question. Well, good luck, and I hope to see you tomorrow in class as we try and solve these problems together.